This is my workstation. This is the place where I spend most of my workday. It's where I play games, pay bills, plan trips, and write code. It's not a traditional desk and chair, but that's kind of the point. I'm a big fan of out-of-the-ordinary computing setups. This particular workstation is called the Cunningham. It's currently in its third revision. The purpose of this video is to be an instructional guide for anyone who may be interested in making a Cunningham workstation of their own. But before we get into how to build one of these, let's talk about some of the design guidelines that I tried to follow while putting this together. Number 1. This needs to be inexpensive. It should be based around a commodity piece of furniture that most people have access to at a reasonable price, and it shouldn't require expensive tools or an entire workshop to create. Number 2. It needs to be comfortable. Comfortable enough to use for an extended period of time. In my case, my entire workday. And number 3. It needs to be self-contained. I've seen a lot of different approaches to workstation chairs over the years, and the ones that are not designed to look like futuristic scorpions tend to rely on multiple pieces of furniture to support the computing peripherals and monitor, and that just seems way too cumbersome to me. So how do those design principles apply to this build? First, the Cunningham is inexpensive. This chair is based around the Poang. It's an easy to source, low cost, and sturdy chair from Ikea. It has a pretty modest price tag new, and it's usually readily available on the secondhand market. Check out your local Craigslist or Facebook Marketplace. Second, the Cunningham is comfortable. I'll admit, this one is a little more subjective. Really, the only way to know for sure is to go into an IKEA store and try sitting in one yourself. I did do a quick Google search, and I found that the Poang is among the best-selling chairs of all time. It's been in constant production since 1977, so there is a decent chance you might find it comfortable too, but it's always worth to give it a try in advance if you can. And lastly, this workstation is self-contained. I think this point is best illustrated by getting into the details of the individual parts of the chair and how they come together, so let's do that now. The Cunningham workstation is made up of 6 parts: the right arm, the left arm platform, the keyboard tray, the Poang chair itself, and a monitor arm. Let's have a look at the right arm. The right arm is a rectangular piece of wood that is 27 1/4 inches long, 2 3/4 wide, and 2 1/4 tall. Each end is cut at a 60-degree angle. The only features in this piece are 3 5/16 holes through the body of the part, 2 of which are counterbore. While making this part, I found it essential to drill the counterbore portion of the holes first with a Forstner or spade bit, and then complete the hole with a 5/16 drill afterwards. The left arm is essentially a duplicate of the right arm, with the main difference being that there is a 3/4 inch notch cut out of the front of the board. There are a couple different ways to cut this notch. I think that the most straightforward would be to use a sliding compound miter saw with a depth stop to slowly nibble out the cut. However, this can definitely also be done with careful use of a hand saw. If you do choose to cut this with a hand saw, I would recommend sizing up the rough part as a full rectangle and cutting the notch, then cutting the 60-degree angles afterwards, so that you have a flat plane in which to cut your notch out. The other notable difference on the left arm is all 3 holes are counterbored, instead of just 2 like on the right arm. The next piece is the left arm pad. This is nothing more than a 14.5 by 8 piece of square plywood. It mates with the notch in the left arm. In my version, I added some curves and cuts because I like the way it looks, but this isn't mandatory. I have included the details of those cuts in the attached drawing if you're interested in duplicating that look. The last piece we need to make is the keyboard tray. This is literally just another piece of rectangular plywood measuring 33 by 16.5. It has one countersunk hole in it, and I did spend some time with a roundover bit and a router to break the edges. If you don't have a router and a roundover bit, the same effect can be achieved with a hand plane or with some sandpaper and a lot of patience. As for the monitor arm, as fun as it would be to try and make this out of wood with hand tools, I think the most sane way to get one of these is to buy one ready-made. I'll link the one that I'm using down below. Okay, now that we have all the parts that we need, let's move on to the assembly process. The very first step in assembling the Cunningham is to mate up the left arm with the left arm platform. I found that the strongest way to do this is with wood glue and clamps. This is my left arm assembly. I fully disassembled my workstation so that I could use it as an example to walk through the assembly process. You might notice I have further customized it with an extra platform and some accessories like a USB switch and a hub. It's really fun to experiment with mounting different accessories onto the Cunningham to see what works best for you and your workflow. Once the left arm assembly is complete, we can move on to mounting the components to the Poang. This is done by clamping the arm assemblies onto the actual chair arms, making sure that the edges are both aligned and that the spacing to the back of the chair is even, around 4 3/4 to 5 inches. Once both arms are in place, tighten down the clamps and using the existing holes in the arms as a guide, drill a 5/16 hole through the arms of the Poang. The arm assemblies are mounted to the Poang using 5/16 carriage bolts, nuts, and washers. These should be readily available at your local hardware store. 2 lengths of carriage bolts are used in the assembly. We will use 4-inch bolts to secure the arms and a longer 6-inch bolt for the keyboard tray. Go ahead and put a 4-inch bolt through each counterboard hole in the arm assembly and secure it with a nut and washer. Try to get this fairly tight. Put the 6-inch carriage bolt through the keyboard tray, and then thread that through the non-counterboard hole in the right arm assembly. This can be fastened down with nuts and washers like the others. However, I did find it helpful to make a sort of handle from a scrap piece of wood and a threaded insert, so that I can tighten and loosen this by hand as desired. This specific bolt acts as kind of a pivot for the keyboard tray, which tends to loosen up as you use it, so keeping it easily adjustable is really handy. Now that the keyboard tray is mounted, it's a good idea to take off the clamps and have a seat to give it a test for comfort. The monitor arm that you choose will determine how you mount it to the chair. The one that I used and have linked below is convenient because it mounts with a single large bolt. I always try to mount the monitor arm in such a way that it acts as a hard stop for the keyboard tray while it's in its 90-degree position. I would recommend using a monitor arm that has some integrated cable management to reduce wire clutter and to avoid the swing of the keyboard tray getting tangled up in a monitor cable. Now that the monitor arm is mounted, all that's left to do is mount the monitor and your peripherals and give it one final test fit. Notice the direction that the monitor swings for getting up and down. Ideally, it should swing inwards towards you as to not put the center of balance of the chair too far forwards. This will stop the chair from wanting to tip in that direction. I was able to achieve this inward swing with a 34-inch ultra-wide monitor, so I'm confident that it's doable with most monitors. And that's it. Nothing left to do but hook up your PC and customize with the accessories of your choice. If you decide that you want to build a Cunningham of your own and would like to share, please leave a comment down below with any tweaks or improvements that you made to the process. Thanks for watching.